Now, there is another special kind of for that goes with enumerate. Now, enumerate was originally not there. I somehow missed it. So do you see enumerate in your file? No, I know. So what I would like you to do is to download a new copy of the PDF and copy paste it. Okay. Or you can well, it's quite a lot. So these two cells I added later on because I forgot about it. Okay, it's there. We're going to be discussing this in chapter 3 as well. It's actually a topic in chapter 3, but I think it belongs with the for loop, and that's why I brought it forward in chapter 2. If you download a new copy of the IPyNB file and maybe give it a new name, then you will be able to copy paste it from a new version of this file. Okay, so now enumerate is again it's same like the for. Okay, what enumerate does is something very special. So instead of just one value, it's going to give you back two values. Enumerate. So instead of you have the same S, right? So instead of saying I in S, we are saying I or value in S. I'm giving two variable names now. I comma value in enumerate S. Okay, so instead of simply saying in S, okay, this syntax is in enumerate S. Okay, so when you use the enumerate keyword, enumerate again within parentheses. Now you give an iterable. Okay, iterable is a list of elements that can be iterated over. So it can be a list or a tuple or a dictionary. Is going to give back two values. It's going to give you the index number and then the value at that index number. So index number means the position in the list. So again, the numbers start with 0. So the first position is 0. So it's going to give you two values. So that one will be the index is 0, value is 1. Okay. And then the next time around is going to give you index of 1, I will be 1, value will be 2.2. Okay. And then index of 2, value is 4. Index of 3, value will be none. Index of 4, value will be 5. So it's going to give you two values. The enumerate function gives you, okay, as it iterates over, is going to give you two values. The positional value, the index, the position where the element is coming from, starting from 0, 1, 2, 3, 4, and then the value itself. Okay, so I and value. So what I'm trying to do is do the same thing like what we did previously. Now this time I want to identify where the non-numeric values are and what those non-numeric values are. So I want to print that out. So which means I need to know where the value is. So I need to know the index number and then what that value, that non-numeric value is. So here once I have, so for IV, okay, or again remember these two are any variable names. You make up the variable name. As long as those variable names are valid names, it's good. Okay? And you want to use some logic there, some rationality, so you will understand what they are. So I being the index, value being the value from the list. So now I check the value, same way like before. Okay, if it is an integer or a floating point value, then I add it. Otherwise, if it is not a valid numerical value, so that's when I want to identify where that value occurs and what that value, that non-numerical value is. So I have an else part here. If this is not true, if it is not a valid number, okay, again you see else colon and then indented. So I'm now printing non-numeric value at index. So I, the index value, and then the value and what the value itself is. So these, anything that appears within quotation mark is simply a string. So the print command will just print that as is, and then that what is not within the quotation mark is a variable, so it's going to print the variable name. So and then I'm printing the total itself. So it goes through. So now you see the I value at 3, so 0, 1, 2, 3, that's where the non-numeric value is, and the value itself is none. Okay. So that's your enumerate. So enumerate is a variation in for loop. It is like for loop, but instead of simply saying for variable initerable, you say for two variable names, okay, and then enumerate in enumerate. So enumerate is what's going to generate two values at a time, and then the in will put it back into those two variable names. Okay. Now the while loop is the same thing, except that it's going to keep on iterating until value is true. Okay. So now I'm going to be using this pop method instead of just looking at the value at a particular position. So when you use pop, what's going to happen is this pop removes the value from the iterator and uses it. Okay. So I'm going to be popping values right at the beginning. Okay, so same code. Now I say while s. Okay. While s means while s is not empty. Okay. So while s, that's the condition. When I set x equal to s dot pop 0, the first element. So it pops out the first element. So that's your x. X will be 1. So now 1 is gone because it's been popped out, right? So then the if checks whether it is a numeric value or not and adds it. Now you go back to while. Now this time s is still a non-empty iterator. Now you pop 0 again. Now 0 this time, since 1 has been removed, 0 is 2. So x is 2 and you go through the computation. Okay, now 2 is gone. So next time around, the value at 0, at the index 0, okay, is 3.4. So again, go through that. Then 4, and then finally when it comes to here, it's not a number, so it's going to skip it, and then the 5. Okay. And this one has one additional number, I guess. Okay. So that's your while loop, and in while loop I've also introduced a new function called .pop. Okay. Pop keeps taking things out of the iterable, whether it is a list or dictionary. Tuple, it cannot do that. Tuple, you cannot do pop. We'll talk about why later on. Okay. And again, this is a very useful function, pop. We'll be seeing pop a few more times. So now we're going to have to iterate over a range of numbers. So we have to use the range function, and that is range 1000. so it's going to be something like that. Right. So we start with a counter. We need to initiate a counter with a 0 counter, right? So start with that. Counter equal to 0, right? And then you have your for loop statement. So that is for, well, this can be anything. You make up any variable name you want. In range, so now we want 0 to 1000. Okay, so what is the number that we should put here? Because if you do 1000, it's going to start from 0 and go all the way up to 9999. 999. Okay, so and then that for statement, okay, should end with a colon. Okay, and now press enter, so you're automatically indented. So now you want to see whether it is divisible by 13. So say if V, right, percentage 13. Percentage is going to give you the modulus. If this is equal to 0, then it is divisible by 13. Right? So now how do we check whether it is, this is 0? Equal to 0? 2 equal to 0, exactly. So equal to 0, then a colon. So now this line of code is only if the if function is true, if the condition that we have in the if is true. If that is true, then we increment the counter by 1. Okay, and then that's it. Okay, if it is not equal to 0, then you don't do anything. So now the for loop is over, so we go all the way back to the starting point, no indenting at all, because your if condition is completed and the for loop is also completed at this point. So you go all the way back and then you print the counter. Right? So that gives you a total of 77 numbers that are divisible by 13.